Looks like almost everybody's here. All right, everyone. So thanks for waiting. Just had to take care of something really quick. There you go. All right. So hope everyone's doing well. Hopefully they had an exciting weekend and things are going well and hopefully not too crazy. All right. So what do we have today? Today we will continue graphing. I know that seems a little mundane, yet it will pick up exactly where we left off last time, where, again, this is you looking at your previous notes, right? I'm referring to the previous lecture PDF right now, and you can see here that we introduce slowly 2 points between whatever line that we're imagining, and we're finding the slope between them. And again, the purpose for the slope is to show you the progression, if you will, of the line, right? In terms of its steepness, how high it's rising and changing, and the rise over run, as you've seen here in the previous one, right? So we'll continue that, and we will do a quick example really quick. And then we'll move to the third graphing option, as long as I haven't missed anything else in terms of what is in the textbook, which I'm going to double check for you all right now. That last left off with calculating slope, and then we can move forward to the third option, as I was alluding to. I don't think that we have anything else after that. I think we finished that section properly. So let's do another example for slope really quick. So here's example 1. And then I'll say again, find the slope between, let's use today's dates, 11, 9, and we'll use negative as well, -1, -1. So that's the instruction you will see on what will be eventually homework in your final, and then you just have to calculate it. So again, in this particular example, you're not graphing anything. We did show you, and by we I mean I, but we went over what it meant visually to see the slope in practice, right? And we won't do it again in this problem or this example, unless people need to see it again. Otherwise, it's just to show the meaning, because the next step I'll show you, it will explain it. Okay. So as usual, when you're doing something formula-based, I always encourage to rewrite the formula. So you have y minus y1 over x2 minus x1. And remember, whether you color code or you write on the top, again, students in the past, they've written it like this, x1, y1, x2, y2, so that they can distinguish them. I'm going to simply write it in a different color so it's more visually aesthetic for those that are watching. So there's your formula, as well as your labeled numbers. I'm going to throw the minus signs there in advance since I have to anyway. So we're going to go -1, and then light blue, that's 9 right there. And again, -1, and then -11. And I also may have mentioned before that notice how we said this was the first point and this was the second. Why did I do that? Well, no reason in particular except for the fact that I read the words or I read the numbers 11, 9 first. And I was saying or reading, and I won't do it here, but I will rewrite it for you. And that is if we had calculated this way, we would or we will get the same answer. And what I mean by that is if I rewrote it as, I'll just put a big or here, or if you had written it minus minus the other way, so minus 1, 9, and 11. So as long as people, and people could mean you as a class, or people I've taught in the past, or people in the future, or people that ever do a slope formula like this. As long as they don't mix up where the x's and the y's are supposed to be, right? Notice how the y's are always on top and the x's are always on bottom. As long as they follow the rules in terms of which points you use first, you'll always get the right answer. In fact, you'll get the right as well as the same answer. So let me finish this one here on the left in black. So what's negative 1 minus 9? That is negative 10. And then what is negative 1 minus 11? That is negative 12. Remember, the negatives do cancel, and then we're left with just 10 over 12, but we have to simplify. So even the slope is susceptible to always, hey, give it to me in simplest terms. But you already know that because any fraction you're supposed to do that. So anyhow, this becomes 5 over 6, right? And then that is the answer here, but what I will write really quickly, again, not a picture, but this is to instill in you that, remember, this is rise over run. So that means you go up 5. This implies that you go up 5, and then you run right 6 because slope is positive. So that's the visual take or interpretation of these 2 points if you're trying to connect them, as well as make any additional points to graph it. And again, you can do this and you can graph and you don't have to calculate anything other than that, but you can see it takes a long time, right? Whereas the first way, the first 2 ways, right, you can make a little, you don't have to write this part down, but we made the little X and Y charts, right? And then you picked some values and then, whatever the number is here and here, and then here and here. And you plot your points and then you draw the graph. So again, this is the easiest, it's just the most tedious. This one is a little bit more eloquent, a little bit more sophisticated, but as you can see, there's a lot more theory here. Not theory to chase you away, just theory to understand that, hey, there's this going on. Okay, so remember how we had these graphs here? So I'll say recall. Before I do, though, what are the questions on this? I know it's over the weekend. People probably weren't seeing this a lot. Okay. As always, stop me if you have anything, and if anybody types a question in the chat, make sure to just let me know so that I could actually acknowledge that question. So I'm going to say here, recall. So if you recall, remember we had these unique lines that were either horizontal or vertical, right? So recall we had lines that were strictly vertical, vertical, or horizontal. For example, we'll say x equals 2. Let me do these in different colors so you can see them. This I will draw the picture. X equals 2, and let's do green. Y equals -3. I'll scroll up and graph these two lines for you really quick. There. Y, X, 1, 2, 3, 4. 1, 2, 3, 4. 2, 3, and 4. 2, 3. Okay. Now, if anyone doesn't mind sharing, who's vertical and who's horizontal again? Is it the Y line or the X line?
The Y is horizontal and the X is vertical.
Beautiful. Thank you, whoever that was. Oops. Okay. So exactly like your classmate said, right there is Y equals -3. It looks a little slanted, but it might be my eyes looking at the screen. So apologies if that's not completely straight. But that's supposed to be parallel to your x-axis, right? And then 2 is right here. So that's x equals 2. All right, so you guys know that. No problem, not a big deal. No harm, no foul, right? However, now that we're talking about slope, right? Now we got this extra layer that we got to worry about. It's like, oh my God, type of thing. So what do we have to worry about? Well, remember how I wrote very in the keep in your back of your mind? It was either last lecture or the lecture before. I said, keep this in the back of your mind. Well, this is it. Since we're talking about slope now, it's the last thing we have to worry about before we move to the next section. So it depends on how you interpret it, but here's the short answer. Y lines are not only horizontal, they are always horizontal. Sorry, I misspelled that. Horizontal. T-A-L-T. They also have a slope. Remember, a slope is M. It's always 0. Okay? Whereas for X lines, right, this implies always sorry, I can't spell today. Always vertical. Now this one's unique. M is undefined. Now if you just want rules and you can remember this, that's great. No problem. But for those that need a little bit more of a why, whether whether you want it or not, I'm going to tell you why right now. But what it is also is that it's important to know the why because, as always, as I explained in the past, it may actually help you a little bit more in terms of how you want to go about memorizing or recalling or just how you can reference this type of information all the time and not worry about it. Okay, so that's that. And Let's try this now. The explanation is that we took the time and we described the horizontal and vertical in terms of how they arise, right? And then if you might go, well, why is it that this is always the case? Well, it turns out that if you use the slope formula and you pick any random recording, sorry, if you wait, if you use the slope formula for, say, we'll do the x line first. So say you choose this point right here, which is 2 comma 2, and you choose this point down here, 2 comma negative 4, right? And then you take the time to calculate the slope here. So m equals minus minus. So you do the y's first, right? So I'm going to do top minus bottom, 2 minus negative 4, and then the x is 2 minus 2. Well, what do you already see happening here? What do we have in the denominator? That's 0, right? Hopefully you notice that immediately. Well, what happens when we have a 0 in the denominator? Doesn't matter what happens up here, right? This implies undefined fraction. Well, if we have an undefined fraction, that means we have an undefined slope. So that's the y right there. Okay. As for the y in the y lines or the y baselines, as I'm pretty sure a lot of you can already visualize, if I say this is the case and then we ask why or how come, when you redo this and you choose 2 points at random, so say I choose something really far off here, which is negative 4, negative 3, and then I choose something here that's 0, negative 3, what you'll find happening is that the y values will be on the top. And then the x values, I'm going to subtract the left side first, so negative 4 minus 0. Well, you'll find out that it doesn't matter what's on the bottom, because what will happen is that this doesn't matter what that is. The fact is that you're always going to get 0 on the top. What does it mean when you have 0 in the numerator? It means that in any fraction, it means 0 overall. And that's why those are the case. So I may have told you, hey, keep this in mind. And again, some of you may have already known it. Some of you may have not. Say, some of you may have forgotten. But that's the accompanying reason as to, oh, this is why that not only do I have to worry about the vertical and the horizontal, if I get an easy question on an exam that asks, hey, what's the slope? You know this will always be the case and you don't have to worry about it moving forward. Okay? So that's the last part in this section with the whole finding the slope and understanding it and drawing a picture. Again, I know I didn't draw the picture for this first example right here, but this second example right here, I guess I can say this is example 2. No, it's not example 2. We'll leave it alone. This is important to know because it will always be the case, right? You're always going to have this. You're always going to see it. You're always going to graph it. You're always going to do something where, excuse me, you're always going to run into it where if you have the vertical or horizontal lines, someone, some way will always bring up the fact that, oh, well, what's the slope in that case? And for those that need a mnemonic device to learn or remember this, I remember when I was teaching high school algebra, and they said, well, you can always remember the horizontal line is slope 0 because it's like you're riding a bike, right? If you have a little bike here and you're going whether it's right or left, the ground is flat, so it's 0, right? But if you are riding a bike and you're at a cliff, well, what happens when you get to the end of the cliff? You just fall, right? You just fall, and then it's like, ah, too bad. And this is like ground 0. That's another way. I mean, I thought it was like a lame example, but you know, some people need a visual for a bike, I guess. So who knows? All right. What questions here, if any? It should be straightforward. The last and final way is that we're going to use something called the slope-intercept formula. And I know that everyone has run into this one way or another in their high school career, or even before university, maybe even before high school, right? Because you always hear the formula, but you may not always use the proper name, right? So our third way to graph, or our third method, I should say, is using the slope-intercept formula. And then we can define it as well. All right, the slope-intercept formula of an equation of a line with slope m and y-intercept. So notice how we're only pulling the y-intercept, right? And again, you may have said, well, what do you mean by y-intercept? Well, we defined that, right? We defined it in the sense that when we were graphing with intercepts only, you knew that the y-intercept was the one that had a 0 in the x spot or x coordinate and a number that wasn't 0 on the y coordinate. But I'll still color code it here. The y-intercept, we'll do it this way, 0, comma, b is y equals m x plus b. Right, so again, the slope-intercept form of an equation of a line with slope m and y-intercept 0, comma b. So they're specifically talking about the y-intercept point, not just any random point. They want the exact y-intercept point is this, right? Another way to think of this, let me use a different color here. This phrase, because it's very easy to get lost sometimes, because you got Y-intercept and then all of a sudden we call it B. Whenever anybody is talking about the Y-intercept, again, they're just meaning the point where a line crosses the y-axis. So for those that will see graphing in a moment, you're going to find out that this is very helpful to keep in mind. And again, in all honesty, it might require a little bit of work, yet I would like to think this is the easiest way to graph. So how do you do it, right? And this is what you do. Let's do an easy example. So suppose they say, example 2, graph y equals 2x plus 1. And obviously, I want you to use the slope-intercept formula. So no plotting points, no intercepts, anything like that. Okay, and we draw our graph. Okay, and what do you do from here? Well, step 1 is to graph some people will give you various ways on what to do first, but this is just what I've always done, right? What you do first is you graph the y-intercept. So here, and use the same colors as well. So here we have a y-intercept of not just 1, but it's positive 1, right? So then you ask yourself, where's positive 1 on the y-axis? I guess I could write that. Step 1. Ask where is D on the y-axis. Then plot. Plot the point. So in our case, it's 1, positive 1, right? So then you know it's going to be right here. 0, 1. Why do I know it's 0, 1 instead of any other number, 1? Again, it is the fact that it's the y-intercept. By definition, it's the y-intercept. It's the point where your line will cross the y-axis, and if it's crossing at the y-axis, as we learned from graphing the intercepts, that means that it has to touch the y-axis, and you can only touch the y-axis if you're not moving in the x direction. In other words, you're not moving left or right, you're only moving up or down. So that's that. Step 2 is to find m, right, or find the slope. Now I write in simplest terms because sometimes your slope may not be in a simplest terms, but most of the time it should be. So where's the slope? Remember, the slope is the number in front of the x. It does not include the x. So in our case, it's not only 2, but again, you should write it as a fraction. It should be 2 over 1. So in our case, in simplest terms, write as a fraction. Because it's going to help you. So here in our case, m is not just 2, it's 2 over 1. Then the last step is to plot the next point using rise over run and remember that's always in the y direction up. And then you run in the x direction. So from 0, 1, right, you're going to do what? You're going to go up to y2 because 2 is in the numerator. So there's 1, 2. Now you don't stop there. That's just the rise portion. And then now you have to worry about the running. Well, we're going to run 1. Why 1? There's a 1 in the denominator. And then I'm going to tell you you're going to run to the right one. Why the right? Well, because it's a positive slope. So you plot your second point right there. Let me make this a little bit clearer. So you plot the second point right there, and all of a sudden you have 2 points, and then you can graph your line. No, that's not good. A little bit steeper. There we go. Yeah, that should be good. And then that's it. So these are now finally a full formal introduction in terms of me showing you, going over some definitions, understanding some other nuances of the how should I say, the properties of graphs and slopes and how to find certain equations. Let me scroll up just a touch. And this is it, right? This is the 3 methods of graphing. I mean, you could argue that there's a combination of these 3, but if you're talking about just strictly, hey, how can you graph? What are the ways to graph on a coordinate plane? These are the 3. Now it's just a matter of showing you how to do this when there's complicated numbers or different things. So obviously I'm going to show you one where it looks like when you have a negative y-intercept and also a negative slope, so you know what's going on, okay? But otherwise, if you follow these 3 things and you get the equation into slope-intercept form, which is the y equals mx plus b form, then you'll get it right every time. You just got to remember which direction you're graphing and the order and all those things that keep in mind when students make little mistakes. They forget a step, they skip a step, or whatever escapes their mind when they're practicing homework exam, right? All right, let's try another example. Before I move on, though, what questions do we have about this method? Just to let you know as well, when the equations are this simple, it's always going to be easy. It's tougher when the equations are a little bit more wacky, right? So again, this next example, I'm not going to make it hard or anything. I'm just going to change some signs so you can see the difference. But I'm going to show you a couple of questions that look a little bit weird. Then you kind of go, oh, okay, I see why it can be tricky at times, okay? So let's do example 3. I'm going to scroll up just a touch. Actually, no, I'll leave this here so people can see. So here's example 3. So I'm going to write just graph, but obviously I want you to graph slope-intercept style, right? So graph y equals negative 2/3 x minus 1. Okay? So what do? Well, you graph, right? Oh, that's a lot of noise outside. There's our graph. What do we do first, right? We got to plot the y-intercept. Again, that's 0, -1. Now, notice the slope. Remember, slope never includes the x variable. It's strictly the number in front. In fact, I will write that again as a reminder for people, because when people take my 311 class, they still make this mistake. So I'll say note slope, or m, is only the number in front. Do not include x in slope related in your slope related, is I say knowledge. Knowledge. There you go. So we rise as well, still rising, right? Rise 2 in this case. There's 1. Here's 2. But now, which way do we run? We're obviously going to rise 2, but then we run 3. Well, which direction, left or right? Well, we're going to run 3 left. And why? Because m is negative. And again, I may have said this or mentioned this 1, 2, 3. when we were first talking about graphing the slope, some people go, well, couldn't I go backwards? Couldn't I go down 2 and then to the right 3? And you can, if you remember to. If you can remember that method, and assuming that all your algebra is correct, yeah, you would be absolutely correct. And I'm not preventing anyone from doing what they remember, especially if you had a good algebra teacher back in the day, right? Why? Who am I to deny your prior knowledge? It's for those that go, oh my goodness, math was never my best subject, and it just pains me to have to think about doing it again. For those students and those mentality, yeah, I want to give you the tools so that you can succeed without having a freak out. And if you do it this way every time, you will get it right, assuming that there aren't any weird little typos, right? For example, you graph on the y-axis instead of the x-axis, right? I've seen students do that before by mistake. They remember to rise and they remember to run, but then they run the wrong direction because they forgot about the negative. Okay, if people miss out on the rules I'm telling you, then yeah, sure, of course mistakes are bound to happen. But if you do it to a T like this every time, conceptually and also mathematically, it'll make sense. And then for those students that already have a strong grasping of their graph skills, yeah, do it the way you normally do. Just realize that if you do, just show it to me on your work so that I can realize what's happening, and I can understand the method and then go, oh, okay, I see what went crazy here. Where the mishap or the translation error or whatever the case might be, right? So there's an example of a negative one, right? I don't think your textbook tells you anything in terms of a weird slope in terms of, say, negative or fractions, or I'm sorry, decimals or fractions. Double check. Right? What the heck is going on? This is the wrong section. Okay, good. So yeah, this should be fine. Okay, so what happens when they don't give it to you in slope-intercept form immediately? The equation, that is, right? That's very common as well in terms of practice as well as questions on exams. So if you go to example 4 right now, again, it will say graph, but this time they'll tell you or they'll show you something like this. Let's say, I don't want to make up a crazy example, but let's say I do something like, I know. Say I go negative, let's say negative 3 here. And then I'll say negative 4x minus 2y. Will that work? Yeah, that should be good. So say they give you an equation like this, and as you can see, it's not in slope-intercept form, right? It's not in this y equals mx plus b. See, that's the formula that most students remember. When I say slope-intercept form, they might go, what? But if I go, oh, y equals mx plus b, people go, oh, yeah, I remember that. So remember, you have to get this equation, this line that I've basically written out for you, to the form y equals mx plus b so that you can graph this way. And this is the work I was talking about where, yes, slope-intercept form, it might require you to do a little bit of algebra preemptively before you can get the equation you need. Yet once you have the equation, I still think it's the easiest to graph. Okay? So what do you do here? Well, same thing, right? I'm going to add 4x to both sides. Right, which means that 4x's cancel. And what's still here? Negative 2y equals negative 3 and then 4x. I could have written the negative 3 in front, but since we want to stick to y equals mx plus b form, aka slope-intercept form, again, most people, they write the x term, whatever it is, 4x, 1x, 2x, negative 6x, 100x, they always write it in front like this, okay? And then you divide both sides by what? A negative 2, right? Now remember that rule we learned where if you have a single denominator, it splits your fraction. And this is what I was talking about in terms of simplification, right? Obviously, the negative 2's will cancel here on the left. So you're left with just a y. But then it would be very helpful to break it down where some students, what they do is instead of writing it like this, as you see on the right side of the equal sign, they might write it like this instead. So I'll put a big or here. They might still write negative 4x minus 3, but then they will split it where they'll go, oh, divide by negative 2, divide by negative 2, as such. Okay? So again, it's just a matter of personal preference. Are you the type of person that remembers rules easily? So therefore, you can just write it as option 1 here, option 1. Or are you the type of person that goes, well, I understand what you're teaching, but things tend to slip and I need to be reminded. So you may want to go option 2 instead. Either way, they'll give you the correct answer. But once you're done, however, you always want to write it in y equals mx plus b form. So, sorry, this is supposed to be a positive 4 here. Watch out for that. If under the option 2, if you put the negative 4, I don't know why I put that by accident. That was a typo. This is supposed to be a positive 4 here, okay? So you get a positive 4 divided by 2, positive 4x divided by negative 2. You're left with a negative 2x now. And this is what I was talking about. Now you have this negative 3 over negative 2, which is plus 3 halves. But what is 3 halves, really? Three halves is 1 and a... Come on. What's 3 halves?
Isn't it 1 1/2?
Yep, 1.5, right? 1 1/2, 1 1 1.5, right? However you want to think of it. Now, how do you graph this? It's actually the same exact thing with just a little bit of a twist that you have to be a little careful about. And again, when I was looking through examples in your textbook, I didn't see much or a lot in terms of variety or diverse problems that are going to confuse students. but I want to show just enough so that you know, okay, what's going on here. So let me draw the graph again. And then you can see what happens when we have these weird halves here. All right. Y-axis, x-axis here. Draw this a little bit better. All right. Let's draw. I'm gonna draw it to 3 then. 1. Actually, maybe to 4. 2, 3, 4. 1, 2. No, that's not right. It's too close. That's too far. 1, 2, 3, 4. 1, 2, 3, 4. 1. All right. So what do we do first? We got to graph. We have to graph. We got to graph the y-intercept. So it's positive 3 over 2 or positive 1.5. So I'm going to zoom in here so you can see a little bit better that it's not going to be at 1, it's not going to be at 2, but it's going to be right in the middle there. All right. So you got 1 and 2, but you're not plotting there. You're plotting right in between. So there's 0 and 3 halves. And then when I look at the slope, it's negative 2x, right? But not the x, just negative 2 in front of the x. So negative 2. So your slope here, let's do purple, is m equals negative 2, but negative 2 over 1. Now, how do you go about this? Do you move up half so you get the whole number, or do you move up the entire way so that you get full? Well, when you rise only in whole numbers, right? In whole steps. That's one way to think of it. So now when you look at this, right, you go from 1.5 to not 2, but you go from 1.5 to 2.5. And then from 2.5 to 3.5. So that's how you do it. When you have a y-intercept, that is not a regular whole number or whole integer, right? Whether it's 5, -6, 10, -1 million, all those numbers align or line up on a tick, if you will. But when you start having these halves, these thirds, these quarters or whatnot, obviously the more accurate your graph is, the easier it is. In addition to that, though, when we rise, we always rise in whole steps, right? So you can see I rose, yeah, I rose or I rised. When I went up 2, and then you can see I ended up there at 3.5, and then now we have to run what? 1, but in what direction, left or right? So we rose 2 in whole steps. Actually, let me do that in a different color. In whole steps. And then we run 1, but to the left or right?
To the left.
Because?
Is this a negative?
Because the slope is negative, right? Run 1 left because m is negative. Okay, I know I left BC there because, but just to keep it easy. So we run, oops, let me still stay here. So we're going to run left 1. So draw my little arrow there. You don't have to do that. I just do it this way because it's visually pleasing. So there's my left 1. Let me zoom out a little bit so I can draw the line a little bit clearer. And then that's it. Yeah, that's close enough. All right.
Can you give us a problem and then we'll like do it on our own and then come back and go?
Yeah, definitely.
Okay.
Yeah. That was my next plan.
Okay.
There was no, it's a fine. It's a solid question, because sometimes there's times where I do let you practice, and there's some times where I'm like, you don't need to practice this. This one is definitely one of those times because, again, it's not difficult. It's just that people need to just do it, and then they can see it, type of thing. All right. So yes, I'm absolutely going to give you a problem to practice, maybe even two, right? But I'm going to give it to you like this stylization here in example 4, right? Where I don't just feed you or spoon feed you the equation. Obviously, that's how we learn it first, but I think it's better that way. All right. And I'll leave this up here too as a reference. So I'm going to pick one from the book so I don't mess up the example and give you by accident some crazy one. But yes, I also have it on WebEx where anybody can share their, what do you call it? Their screen. So if anybody wants to, oh no, never mind. I just realized you might be able to share the screen, but unless you're on an iPad and you're on writing on something, you won't be able to do it. And I don't want anyone to, unless you're on a phone. If you're on a phone, then you can like share your camera, and then I think you can. I don't know. Don't worry about it. All right, let me give you an example. So let's do this one right here. Let's go. What's the problem I have here in the textbook? All right, 2x plus 3y equals -9. All right, so here's example 4. I left it up there for you. You already know what y equals mx plus b form, so I'll scroll up just a touch. So I'll leave that there. Go ahead, try this on your own, please. I'll give you about 5 minutes or so to do that, and then we'll reconvene. Water. All right. How's everyone doing? No one's writing on a.
Good.
Thanks for asking. No one's writing on, however, a method where they can share, right? No.
But
No one's on an iPad or anything, or
no.
okay.
But I can like explain what I did. I mean, I don't know if it's right, but
Oh, I'm sure it is right. I'm very positive that's right. I feel that the class does their best in terms of doing their best and trying to explain and everything of that nature. So, what did you get for this equation in slope-intercept form?
so I like switched it to y equals 2x over negative 3 minus 3.
Over negative 3 minus 3. Did other people get that?
Yeah.
All right, cool. So just for completeness sake, I'm going to do it really quick here, just in case if anybody's reading this or watching this later. Yeah, what's the question?
Isn't the 2 supposed to be negative?
The
Over here it says y equals 2x over negative 3.
It is, yet you all learned at one point though that oops, 3, 3, and 3. So then y equals negative 2 thirds x minus 3. So this checks up. Excellent job. Yes, it is a negative 2 technically, yet you learned what in the past when you have a negative fraction. If you have negative a over b, that's equal to what again?
Positive a and negative b.
Yep. You learn like this or like this. However, it is not equal to negative a over negative b, because when you divide two negatives, then it becomes a positive number. Now, it is possible, because I think it was Mia that gave this answer, that when she said, oh, over a negative 3, I may have just heard it late, and then I scribbled it in that way. So that was possibly a me type of thing in terms of how I'm writing it. The good news, though, is that as long as you have the negative sign somewhere, it's still correct. So this is the algebra for it. Hopefully that answers your question. So just remember this. This is very important. Okay.
Yeah, I forgot about that. I'm sorry.
No, don't be sorry.
Thank you.
Remember. It's like the Lion King, right? When Mufasa goes, remember, remember, that type of thing. So there's that, right? Now, how do we graph this? Let me draw our grid really quick. There's x, y. We're going to be starting in negative 3, so we definitely have to go down a bit. 1, 2, 3, 4. 1, 2, 3, 4. And the nice thing is that once you get an idea of how the graph will look like, you don't have to draw your XY coordinate, if you will, this massive. I do it because it's just I have the real estate here, digital real estate, to utilize this. But if you're writing on, say, homework on a piece of paper and you don't want to take up so much massive amounts of space, you can condense. You can draw the graph where you know the direction of the graph is going. That's the nice thing about this. You already know the direction of the graph by just looking at this and understanding this slope-intercept form. When you have plotting points, you don't know which way the graph is going to go until you plot the points. If you use y and x intercept or x and y intercept, you have a general idea, but you don't know how big or how small or whatever the case may be. You just know this on the x-axis, this on the y-axis. Knowing the equation in slope-intercept form and how to graph it up from there, it just presents more information without even you having to do more work. Okay, so we start here, negative 3. So where's that? Me, are you still going with this, or someone else is going to help us?
Oh, I can help.
Yeah.
So on like the y-axis, it was -3 on
So
the
is
y.
that the top or the bottom?
On the bottom.
Perfect. I mean, I know you're saying it correctly. It's just that for anybody that rewatches this, they can go like, "Oh yeah, that's what she meant." So excellent. And then our slope is just the -2/3, right? And then
Um,
what do we do with that?
so rise 2,
Yep.
and then what run 3 to the left because it's negative.
Perfect. Beautiful. Yep, that's all you had to do. So there's that. And she answered my follow-up question as to why, right? We do 3 because obviously it's in the denominator, but we run to the left because the slope is negative. And then let me draw your little line here, and then you're good to go. So for everyone else, how did that feel? Decent, good, bad, indifferent?
It was good. All right.
Do we need to practice another one?
It couldn't hurt.
All right, because how much time do we have left? Okay, the next concept that is involved with this, it does align with what we're doing right now. The good news is that you're not learning anything different. It's just a different aspect of the slope-intercept formula that you have to watch out for. And as always, we can have a small discussion on it, and then after that, you realize that, oh, okay, cool, it's something I just got to keep an eye out for. The textbook does go over saying, oh, choose the most convenient method to graph, right? When they show you a whole bunch of random equations. In fact, I can share it with you right now really quick on the screen because I don't want to recopy it and just waste time like that. So let me show you what I'm talking about. In the textbook, they talk about algebra. Here we go. So it's on page 495, so let me get there. And I'm going to screenshot it so that I can insert it into the lecture. But again, it's not the golden rule or something like that to follow by, right? So here, let me take a screenshot of this. All right. And then we're going to go here, here. I'm going to share this to Notability, add it to our current note. Yes. And then what you'll see is they talk about, put on the side here. Yeah, this isn't bad. See, they discuss, oh, what would you do if you had these equations, right? If you were given equations 1 through 6 right there, what's easiest method to do it, right? And you can see that for the first 2 equations, they discuss in the textbook that, oh, like those are lines. You can just graph them right away. You can even plot like a point or two just to ensure that you're in the right direction. Numbers 3 and 4, you can see that they are in a form that will accept intercepts, right? And so that's why it may appear to be easier, but I'm going to already tell you that from my personal experience, even if I was in the form of number 3 and number 4, I think it's easier to just put it into Slope-Intercept formula and then go from there, because if you always graph that way, you'll always get it correct. And sure, if you always use the intercepts, you'll get it correct too. It's just that I feel that the need to calculate an equation twice, why do that when I can manipulate the formula once, if that makes sense, right? So textbook goes on to onward describing that, and obviously you don't have to do that right now. And I just wanted to point it out to you. But there is something that I do want to show you once I give you one last example here. Okay, so that's just something I wanted to point out here. And I'll even draw a little line here. I'll just call it strategies, loosely, strategies to pick which graphing method dot dot dot, but I like, again, this is just my personal preference, but your teacher, prefer y equals mx plus b every time. And of course, I'll draw a little asterisk here. Obviously, I'm not going to use slope-intercept formula when I have x equals 2, y equals 4 type of nonsense. But you get the general gist of what I'm going at. All right, here's example 6. And then what we'll do is that we'll bring up the last topic, which has to do with what are known as parallel and perpendicular lines. And like I said, the cool thing is that you don't have to learn anything new. It's just when you see the formulas, you'll just have to interpret them a little bit differently so that you know what's going on. Okay? So let's look at this one. Let's do one that's not too crazy. So we'll go, let's go, times 2 is 8x plus 8y. No, that's wrong. 8x plus 4y plus 4 equals 0. So you can see now that this one is almost in that ax plus by equals c form, but I just wrote everything on one side. And of course, you all know how to compensate for that. Let me just make sure I don't have any typos there. 8x plus 4y plus 4 equals. Okay, yeah, that's good. So go ahead and try that one, please. All right, so that was 5 minutes there. So this time I'll just do this one really quickly so that you can check your work, because I want to spend the last 15 minutes to talk about parallel and perpendicular lines. So next time I'm always happy to take volunteers. So we're going to subtract 8x on both sides here. But we're also going to subtract that 4 as well. Might as well knock it out in one fellow swoop, right? So these cancel. These cancel. You're left with 4y equals negative 8x minus 4. And then you divide by 4 on each piece, again, for those that need it, that proper scaffolding. And then you're left with a negative 2x minus 1. So hopefully people got that. This is the equation we're going to use. And then if we're going to graph this bad boy, so I didn't pick a weird half or third or quarter this time. I'll probably have that assigned to you just so you can practice something more difficult, so that when you run into something simple, you can fish it out very easily. So there's negative 1. And for those that were curious, you don't have to label the points like I do here, 0, negative 1. That's just for, again, your assistance. And then you know that the slope is not negative 2x, but negative, not just negative 2 as well, but negative 2 over 1 to help you graph. So we're going to go up 2, 1, 2, and we're going to run to that left just 1 unit. Now, I may have also not mentioned this, but there are some properties that you can understand about the graph just by knowing the slope. And they're not necessary, yet it's helpful in terms of imagining what the graphing will be. Again, I know that we're graphing a lot right now because the next chapter, it's going to be a lot of algebra heavy, but then you'll find out that when we get to the chapter after that, because we're only 2 chapters away from being done in the algebra textbook, 2 chapters from that, you're going to see a lot of graphing again. So it might seem like a lot right now, but it's to prep you in anticipation for more graphs, because we're going to do multiple graphs if you haven't figured it out already. So a couple things to recall. So that's the graph right there. Actually, before I start talking about these properties, what questions do we have there? All right, cool. So a couple of things, some properties of slope. If you haven't noticed already, if you have a positive slope, right? If m is positive, now instead of me writing it out like that, if m is positive, some people write like this, if m is greater than 0, right? We can start getting more mathy, if you will, in terms of our language. But if m is positive, then the graph goes up in the right. No, you know what? Hold on. Then the graph goes up in the right direction. I don't know if I want to say it that way, but I'm going to leave it like that right now because I can't think of a more elegant way of saying it. So what do I mean by that? Direction, T-I-O-N. So in other words, if you have a graph, right, and it's positive, it's going to go in this direction, right? See how you can imagine if you had the axes like this? Let me do this in a different color. So if you had the axes like this, right? Positive slopes always go in this direction. And if I was there in person, right, I would say, hey, just remember this is the x-axis and this is the positive side, and this is the negative side. So you can see I would do this little dance where I would use my hands and I would say, oh, look, notice how the line is going towards the positive direction here, right? Because if they're negative, then they go towards the line. Once it goes above the x-axis, it goes towards the negative. So I'll show you that right now. If m is less than 0, then the graph again goes up, right? Goes up is a very non-mathematical way of describing it, but when you see it visually, you'll see what I'm talking about. In the left direction, or another way you can think of this is, as I said just earlier right now, left direction, or x-axis negative. Right, so if you had a graph again, coordinate plane like this, and again you have negative on this left side, positive on the right side, a negative graph will always go like this. So you see how both graphs go up. Okay, there's no misconstruing that concept, right? Once you get to a certain point, they're going to go in an upward direction. But you can see on the first one, the purple line is going up and to the right, and on the second one, you see the light blue line go up and to the left. Okay. There's also a couple of other things too. If m is greater than 1, right, then you'll have then your graph will have a steep slope. So in other words, if you're more than 1, right, you'll have a line that goes pretty much in a very upward direction, right? And then if your slope is the same, m is less than -1, you'll have another steep slope, but again, it'll be in the negative direction. So this one's a little bit weird to explain because you can see that, oh, if m is greater than 1, you'll have a steep slope, but then if m is less than -1, it'll still be a steep slope, right? So then what does that leave in between? So then you have something like this. If m is between -1 and +1, then your graph will have a shallow slope. So that's how you have problems sometimes when you graph them. You have like a really crazy low line that looks like almost, oh, I guess like a ramp almost, if you will. Something like that you'll see in real life. And if you scroll up to our previous problems, right? So I know people are still writing this, but hold your thought for a moment. If you go back to the very beginning when we started graphing, right? Here you can see that y equals no, not y. Yeah, y equals -3. It's that green horizontal line. Well, notice how, I'm going to use a different color now. Notice how, no, I'll use a brighter color. Notice how the slope is 0, right? It's between -1 and 1. So it's quite shallow. In this case, it's straight, right? If you look at this one, see how the slope is 2, or 2 over 1 in this case, right? So you can see it's very steep. It's going in the upward to the right because it's positive, but notice how it's greater than 1, it's very steep. Whereas this one, notice how it is negative m is equal to -2 over 3, right? That is a shallow line. And I know it looks steep here, but when you look in the whole scheme of things, yes, it's going down at what looks like a very accelerated rate. That's just because of the way I drew it. But you can see it's well, not very shallow. It's shallow, right? And then example 4, here we go, same thing, right? -2 over 1. So you can see even if it's negative, it's going upward this time to the left, but again, see a very steep slope. So you have a steep line. And then same thing here, right? This one is shallow. This example, wow, all my examples were -2. I'm sorry, that was by mistake. So you can see the slope here is also quite steep as well. We'll do more different and diverse examples right there. So that's what I mean right there. So this is important to notice right there. And there's no nice way of putting these two together right here. But if you had to, you could write something like m greater than 1 or m less than -1. You could say it like that. But you can see that from the fourth property, it's a lot nicer to put it in one inequality. Now, these are only, what, 4 properties of slope? We actually have 2 more that we have to talk about that relates to perpendicular and parallel lines. But obviously we're running out of time right now, and I don't want to hold you over than we did. But in the last 3 minutes or so, what questions do we have about not only graphing the third method with the slope-intercept formula, but now we're getting into the nitty-gritty of, hey, how can I understand this graph by just looking at the equation, and I have to exhaust all this time to graph it? I mean, eventually you'll graph it, but once you have an image of what the heck's going on, then it doesn't seem so hard, because then you have these little checkpoints, if you will, that you can self-check. What questions do we have here? None? All right, so let me stop recording here.